Lesson 7-4, we're going to be expanding on our knowledge of parallelograms and relating it to rectangles, rhombuses, and squares. All of the information that we basically learned prior to this, all about parallelograms, will then be applied today. And I know that the learning targets look a little long, but a lot of them are straight definitions that you've seen before, or it seems pretty basic knowing that if it's a parallelogram, then it also would apply to other shapes as well. So I know that a square is a quadrilateral whose sides and angles are equal, is kind of straight definition. I know a rhombus is a quadrilateral, all of whose sides are equal. I know all rectangles and rhombuses are parallelograms. The diagonals of a rectangle are equal, and the diagonals of a rhombus are perpendicular. So we're going to get into those definitions here in just a second, but I just want to remind you from pre-algebra, possibly a diagram that you've seen before, in the fact of you kind of, again, the basics of it is you start up at the top and you say, all right, is it a quadrilateral? Yes. Well, then it can either be a trapezoid or it could be a parallelogram, and you would go down the list. Now, if it's neither of those, then it would just stay a straight quadrilateral. So everything down from there, basically, if I say, yes, it is a quadrilateral, does not necessarily mean it's any of the rest of these down here. But if I say, for example, that it is a parallelogram, well, then I know that it has four sides, so I know it's a quadrilateral. So moving up, everything is the shapes above it. So if I start with the square down here, as it states down here, a square is both a rectangle and a rhombus. So a square is rhombus and rectangle, which means it's also a parallelogram, which means a square is also a quadrilateral. We're not going to talk necessarily a lot about trapezoids today, so we're just going to kind of be dealing with this piece of it. And so all those definitions that we learned about parallelograms before will then apply to these ones down here, because we know that these three are parallelograms as well. Here's another diagram if you want to just kind of take a look at it just to help you out. If you want to draw it just because you like this type of diagram better, just to be able to understand it. But again, squares are right in the middle, which means that a square is a rectangle and it's a rhombus. It's that intersection of both of them. And parallelograms encompass all of that there. So first definition, that when we reference a square, what we are saying is that it's a quadrilateral, all of whose sides and angles are equal. That's kind of the straight definition. Now you want to sit there and you want to say, well, that means that all of its angles are 90 degrees. Yes, that's true, and we can relate that to kind of our interior of a quadrilateral, knowing that it's 360 degrees and all of them are equal. Therefore, if I took 360 and divided by 4, that would equal 90. But again, straight definition is just, basic of angles are equal, which then would infer that, yes, it is a right angle there. Also note that, again, as we stated before, a square is a rhombus with all four of its angles equal, and a rectangle or a square is a rectangle with all four sides equal. So again, if you think about the definition that we've seen before of a rectangle, we've said that has all angles are equal, but not necessarily its sides. Well, a square is a rectangle, meaning it has all the angles equal with four equal sides. A rhombus, which we'll find out here in a second, has all equal sides, not necessarily of equal angles, which is exactly what I just stated. So a rhombus is a quadrilateral, all of whose sides are equal. And so when we get more specific into a square, we're just saying that all of them are equal, all the sides are equal, and the angles are equal. But with a rhombus, it's just the sides that we're dealing with here. So it could be a diamond shape, as you've seen before. All rectangles are parallelograms, which means that basically everything that we've covered so far with our parallelograms, all the theorems that have been involved with that have applied to rectangles, and in 7-3 we proved one of those in the last video. So if you don't remember that one, why don't you take a look back at your notes and just remind yourself that we used the fact that it was a parallelogram to prove that it was a rectangle. Next one is the diagonals of a rhombus are perpendicular. So we proved that with parallelograms that the diagonals bisect each other, which is true for a rhombus as well, but it takes it a step further, which basically states that it is also perpendicular. Because of the fact that their sides are equal, we would then be able to create a proof that then would be able to prove that all the angles on the inside here would be right angles, and the sides would then be perpendicular. The diagonals of a rectangle are equal, so then that is kind of a different version of the theorem we just wrote down for the rhombuses. But this one doesn't say that they're perpendicular, but does say that they are equal to each other as you then draw them from D to B and C to A. Now, if you think about it for a square, then that would mean that they would both be equal and they would be perpendicular to each other, because a square is a rectangle and a rhombus at the same exact time. So just keep that in mind as you're going through. And so what I'm going to do is I'm going to leave you with this theorem here, which is, given that it's a rectangle, so think about what our definition of a rectangle is that I stated earlier. I want you to prove that that is actually true, that the diagonals are actually equal to each other. So AC is equal to BD. And so here's my statements here, is that ABCD is a rectangle. I would then be able to conclude that angle BAD is equal to angle CDA. And then I would go so on and so forth. So with this said, again, draw this figure here and try to put some of the information into it as you go down, but give me the reasons for our next class. So I will leave you with that to try, and have a good rest of your day, and we will see you next class period.